Okay, let's first start by finding what the CDF looks like for the interval -1 to 0, where in that case f of x is defined as x plus 1. Okay, so in that case, in order to find the CDF, we need to integrate starting at the lower endpoint of the interval, which is -1, up to some point x, the function t plus 1 dt. When we integrate t plus 1 dt, we get t squared over 2 plus t, and t is equal to -1, and t is equal to x. Now in that case, when t is equal to x, we get x squared over 2 plus x, and when t is equal to 1, we get, or -1, we get 1/2 minus 1. Simplifying, we get x squared over 2 plus x. Minus a minus a half becomes a plus 1/2. And then that can be written as 1/2 of x plus 1 squared. Okay? So we found what the CDF looks like over the interval from -1 to 0. Now let's find it for the interval from 0 to 1, where f of x is defined as 1 minus x. Okay, now there's one extra thing that we need to take care of here, is the probability is accumulating at a different rate now over this interval than it did over the interval from -1 to 0. But some of the probability has already been accumulated, so we need to make sure that we add that into our cumulative distribution function here. So let's evaluate using the CDF that we just found. What happens, how much probability has accumulated by the time you're at x equals 0? Well, f of 0 is using this formula right here. It's 1/2 of 0 plus 1 squared, which is 1/2. Which shouldn't be surprising. If you look at the symmetry of the PDF, it seems reasonable that we should have accumulated half of the probability at this point. Okay, so now in order to find the CDF over the interval from x is 0 to 1, we need to add in that 1/2 and then accumulate any new probability at a different rate. We need to do that by integrating from x is 0, I should say t is 0 to x, the function 1 minus t dt. So then in that case we get 1/2 plus integrating 1 minus t dt, we get t minus t squared over 2. And that's evaluated at t is equal to 0 and t is equal to x. So we get 1/2 plus, when t is equal to x, we get x minus x squared over 2. And then when t is equal to 0, we of course get 0 there. So the function f of x is equal to 1/2 plus x minus x squared over 2, which if you do a little bit of work, you can show that that equals 1 minus x all squared over 2.